Start streaming, connecting, start watching. Up, the stream should be on. I just want to check the audio. The audio is not there. Live, but there is no audio. Why don't I see the audio? Ah, yeah. On mute. I should hear myself. HDMI. Okay, audio is good enough. I have to tweak this a bit. It's even a bit too loud. Okay, now it shouldn't overdrive. So, welcome back. I wasn't there the last 2 weeks because of two things. I did the video, so I released a video last week, and most importantly, I had no bandwidth. My internet got even worse, and it wasn't even possible to stream any 720p. It was impossible to stream anything or to watch any video. So I decided to cancel the contract without notice because they didn't deliver the bandwidth they promised, and I have new internet with a lot better bandwidth, and I am able to stream even in HD. And this is what you're looking at now. And we're back into streaming, and we can work again. Today I wanted to do something rather simple. Changing. I've talked last week about bench multimeters or about multimeters in general, and I'll show the multimeters. But the idea, the plan here, is to take this multimeter and have it a bench multimeter. With bench multimeter, I mean that if you look at the stream here, you see I have my 2 multimeters on the bench, and I just take them wherever I want, whenever I need to place them. But to be honest, they take place here, they cover up the axis, and also most of the time I just want it here and the screen is big enough. So I will transform this into a bench multimeter. By bench multimeter, I mean one that is always powered on and one which is at a fixed location. I don't know the location yet. I think I will just put it on top of the oscilloscope if this works. Or next to the oscilloscope. Here it would be actually ideal, where the arm of the camera is. Up. I think I will put it here so it's in the way of the camera, but I can still move it away if I need to. Let's put a bit of space here. I think that will be the solution. I don't have a lot of space right here, and this what you don't see here is actually the arm of the camera. Let me switch up here. This is not holding very tightly. Here. So here you see my bench with oscilloscope, power supply, plenty of USB power supply with kind of a way to tell how much it draws power or current. Not very precise, but it indicates at least if it's charging or not. And then we have 2 power supplies where I can change the voltage and the current. And this is not holding. And yeah, so I think I will have, and this is the arm of the other camera. I think I will put it somewhere around here because I don't have any space else. Ideally, a bench multimeter should be sitting right here, something like that. But the screen is horizontal, so I cannot put it vertically without having it disturbing. Although I could. I just have to read vertically, which is also okay. Get used to it, I think. Yeah, it's not a bad idea. Having it this way, so this way it's not in the arm. And I can read it vertically. You just have to think a bit about it until I have more space. I think that's how we'll do it. But the idea is having transform it. So multimeters. I have plenty of multimeters which grow over the time. So I had the cheap, really cheap yellow ones, squarish, where you select the range and you get them for $2. You get them sometimes for free. I don't have this one anymore. And the next one, when I started electronics, I got is this one. Let's switch again. Angle. It's this one, which I got at the second place. This is a Fluke 17B. It's not released in Europe. It was only released in China. And for that, it was really inexpensive. So I think I paid around $30 for it. And I don't use it very often, simply because the first setting here is volt AC and not volt DC, and I'm doing electronics. So I'm using it, this one, I'm only using it if I do high power or high voltage. High current, high power, high voltage, because I'm more confident in this one not blowing up, having the right fuses and so on. And it is probably more meant for electricians than electronic guys. So this one, the one I got, I almost never use it, although it works well. Next one I got is I have a drawer. Let me put them somewhere where it's not in the way. The next one I got is this one, I think. Yeah, I think it was the second one. Up with glaring. So that's the Unity UTC61B. And I got it because it was super cheap. I mean, it does all the work and it has 4,000 counts. And I think I can still recommend it. It's robust. It's good enough with 4,000 counts. It does electronics, so you start with voltage DC. That was the most important part. What can I say? It was cheap. Although by now I do have other leads. I don't have the one which were provided. I have better leads with sharp golden needle tips. So that was the second one. Afterward, I got, I think, the third one, because one multimeter is generally not enough. Sometimes it is already measuring something, so you don't want it to reuse it, and most of the time you want to measure voltage and current, so that's why you need at least 2 multimeters, and I really recommend having 2 multimeters. That was the second one I got. This is the 61E. Almost the same thing, same settings, but what changed it is true RMS. The other one was not true RMS, although I don't care because I'm not doing AC, I'm only doing DC, so the RMS is even if they're whenever I'm doing AC, it's just for measuring sine waves for the mains power. So not true RMS, and having the approximation of having a sine wave is plenty good enough for me. This one is true RMS though, I don't really care. What's most important is the 22,000 counts. And this makes, I don't really care about the accuracy, but the resolution is high. So if it's not 1 volt, but in reality 1.1 volt, yeah, I don't really care. Although it's not that bad. But you can see the last digit going up and down, and that's sometimes very useful for the electronics to see things charge, discharge, and see small fluctuations. The problem with this one, why I don't use it very often, is that, well, problem and advantage. I bought it for that. The port on the side here streams data, and you see also it's enabled by default, and it doesn't have any timeout. This means that if you forget to switch it off, after 5 minutes it will not switch off, and it will drain completely the battery. While this one although it has also the port on the back to send out the data, you have to enable it first by pressing on the button and holding the button. And else it will just time out. So after 5 minutes, or I don't remember exactly how much time, it will just switch off, which this one doesn't have. This is why I'm not using it very often. And let's first talk about multimeters, and then let's talk about what I did with them. So that was my third multimeters. And no, actually it was my fourth. I had one in between, which when I was doing abroad internship, I bought one because I just needed it, and it was also cheap. And I quite like it actually, although I never use it because it's very clunky. The resolution and so on is not very good, but I like it quite a lot because it tells you, well, it is robust, it does the job as multimeter, but what I found very good for this one as for beginners is that, so which is this one, Mastec MS8268. It tells you which port to use. For example, you see, I disconnected it and it tells connect here. Same here, I disconnected, it tells me I have to connect the lead here. And now if I go to measuring current, it will beep and flash. So you don't hear the flash, but at the same time it beep and it tells you're not connected to the right port. When you disconnect, it says you have to plug something here, and then you plug it here. And if you go to voltage again, same thing. So this is really very user-friendly when you're not very used to multimeters, because you don't blow up things this way. For example, if you wanted to measure voltage, but you forgot that you are in current mode, and you will shunt it, and you might blow up something. So I like the feature in this one, and else it does really the job. But I use it even less often than the Fluke. It's just there if I need a third or fourth multimeter. Also because the accuracy is not really high and the resolution is not high. But this feature of having plugs light up is really a good thing. And for that, I could recommend a Mastec for beginners also. By now, we have something else. So that was the next multimeter, and the last multimeter I got, which we can call a multimeter, because I wanted. Oh, no, it's not the last one. Next one. So my 1, 2, 3, 4, fifth multimeter is this one. Let me roll off. This is the Aneng AN 8009. It's increased to 8008. 8008 was the first one, and I think 8009 adds, I think, temperature and NVC, so non-contact voltage, where you just can scan 200 volts if you're next to it. And I really like this one, and it is very cheap. It is I think under $20, $15, something like that. It comes with okay leads. The screen is really big. The resolution is good enough for most of the thing. And for this price, because it is so small and the screen is so big, I throw it in my bag whenever I do something in electronics, because yeah, it does most of the job. So compared to this really clunky one, you see the size difference? This fits in the bag perfectly and does most of the job. I think there's one thing which I don't like here. Well, two things. One, it doesn't have any external port, this one has, and I wanted a multimeter with an external port. This is why after the Fluke I bought this one. I wanted to read the measurements with on the computer, so this doesn't have this at all. But I didn't mean it to have it. It's kind of you could think of a drawback, but I didn't want, because I already have two which have the output. The second biggest drawback is the milliamp range. It doesn't have a 10 milliamp range or 40 milliamp range, whatever you want, in this range. So it's either 600 or 400 or 4 milliamps, nothing in between. So for measuring small currents, not really tiny currents, but small normal currents, electronic currents, it's not very good. Although this has been fixed, I think, in the newer one, I think 9012, 8012, I don't know, they added this missing range. But I don't have the newer one. But still, I really like this one, and if you want to buy a cheap one, a throwaway one, this one is a good choice. That was my 5th multimeter, and I have almost a last one. So this actually this was the bag for the first multimeter, and this is my all-around bag for if I go somewhere. I can put this bag in a bigger bag, and it has everything I need for working on electronics or for working in general, screwdrivers and so on. This is my electronic starter kit. I showed it in a video. I think the one with the humidifier, and this one, this is the last one I got. Also an Anang, I don't remember exactly. So this category is even smaller. I wanted to have something. So this is nice. You can fit it in the bag, but if I put it here, it already takes a lot of space. So I wanted a pocket multimeter, and this is what it is. It is even smaller. See, it's less thick. It is less big, so it is even smaller. The leads are crappy. Okay, the resolution is crappy. I don't care, and you have only 2 leads, so you can short it if you make milliamps or voltage, because you don't switch the leads. But I really don't care. What I wanted is a small one which I can fit anywhere, and this does the job pretty well. So pocket multimeter, and here is a coin cell battery where I've modded it actually. Here you see a USB port. This is not original. I've added a USB charger. So inside here we don't have a CR2025. We have a LiPo in the same form factor, 2032, things like that, a bit bigger. And I can charge it using this board. You can see also it's not perfect. I have a small bulge here, but when you operate it, you don't see it. So whenever this is flat, I don't have to change the battery. I just need to put the USB port. This is mostly important because this is a travel bag. So whenever I'm somewhere else, I don't have a second coin cell. And I don't want to go buy something. This is why I can still plug it my USB, wait 10 minutes to have it charge a bit, and then reuse it. This is the modification I did. And this is kind of all the multimeters. No, it's not all the multimeters, but all the multimeters in the sense that you would think about multimeters. I also have still other multimeters, which are more specialized, a lot more specialized. Let me put this back. Let me get the next one. More specialized multimeters. This one, and this one. These are the more specialized one. Yeah. So let's start with this one. This is actually when I did my electricity, my spark counter and spark abacus, the electricity meters. I got this thing. This is really there to measure voltages, measure the electricity. So it's very simple. It cannot measure any current. It doesn't measure any resistance. It's just there to measure voltage. But it's really useful because it works also with just one. Whenever you put it in a plug, you will still see the voltage. If it's dangerous or not, you will see it blinking. Let me try to show you. So here we have power. I shut it on. And the sticks are really long. And now if I am able to, there's the child safety. This is a pain. I have to get rid. Let's switch this off. How can I get rid of this child safety? Okay, now. You see, just with one, it makes, you don't see the, yep. It is very faint, but you can see some lights going on. So it does tell that there is some dangerous AC voltage, although there's only one probe. And it's very useful to test electricity without having the two probes connected, which you would need to do with a normal multimeter. So this is really meant for electricians, and it has long plugs, so you don't put your fingers. Like with this short plugs, you don't short anything because it has protection caps, and you just test the fuses in a fuse box. This is why I got this one, because I really did electricity. I did some part of the electricity at my home. And this is specialized, so this is an electrician's multimeter. Next one I got was, or I have, is this one. This is also very specialized because it is meant for SMT tweak. These are SMD tweezers, so it's meant for really tiny electronics where you have something on the board already, or you have very tiny components, and with one hand you can actually identify the components. It can read voltage, but what's most important, it can test LEDs, it can measure resistance. So for SMD parts, surface mount SMD parts, this is a lot more easier to use than having two probes connected. So yeah, it's an like it says, SMD meter, hold peak HP 990B. I don't care about the brand. It does the job. So for SMD parts and for testing SMD parts like LEDs and small things, this is useful. The last one I have is this one. This is a clamp meter. So yeah, multimeter specialized for measuring currents. You can plug leads here, so you can measure voltages. I never use them though. What I use it for is just measuring current. So what you do is plug this around the cable. This is the wrong way to do it, but the idea is that you don't have to contact, or you don't have to cut the cable, because you can measure the current which is going through thanks to the Hall effect sensor here inside, and it will tell you how much currents go through. And this one you can even, as you can see, it is marked hacked because I changed it, and it does DC per default instead of AC, and instead of 6 amp in this range and 20 amps in this range, I hacked it to do 6 and 70 milliamp, 6 and 60 amps, and I added a milliamp range. You can do this because inside there's an EEPROM telling for the configuration, and you can just change some parameters in the EEPROM. You have to keep the calibration data because it's been calibrated, although it's not very important for my case, because I want very rough measurements. And using this, I can measure currents being in the milliamp range, so AC and DC currents, and really useful because you just have you don't have to cut the cable, you just put this around the cable. So clamp meter. Another thing, but I don't use it very often, which is an advantage, is whenever you're doing electricity in your house or somewhere else, you always need to somehow, because you have two leads, you have both hands, you're using both hands, and you don't have a third hand to hold your multimeter. So you always need to find somewhere where to place the multimeter or to hang the multimeter. Here we have a stand. Some multimeters have a hook, or you can put a hook. This solves this issue because here is a clamp. So you can buy it here. So you can actually clamp it almost anywhere, and then you have the two leads which are coming out. So this is another advantage, but because I never measure voltages, I don't use this advantage. But you could use this for clamp meter. And these are all the multimeters I got. And I think with that, the topic about multimeters is closed. And in the next videos, I won't have to show all of them because I already did. So let's come back to the topic today, which is transforming the handheld multimeter into a bench multimeter, and I will use this one. So here there was an issue I had with this one. It is, I'll open it. It uses 9-volt batteries. So it uses 9-volt batteries, and if you leave it switch on, it doesn't auto switch off, so it chews on the 9-volt batteries. 9-volt batteries are not very common. Rechargeable ones are very rare, and a charger for 9-volt batteries is not easy to get. AAA batteries are a lot better, but multimeters for a long time had 9 volts. Most of them now have a double A battery or AAA battery, and this is also why I quite like this one, because it doesn't use this pesky 9-volt batteries. It uses AAA batteries inside. Huge advantage because they're easy to get and they're easy to charge. This one has 9-volt battery. It looks like this, and as you already see, what I did is change it. So this is not an original 9-volt battery, it's something like this. It's a rechargeable 9-volt battery, but you don't need the charger for 9-volt dedicated. You just need micro USB, because what is inside is a lithium polymer battery, which is here, lithium ion battery, rechargeable. And it has a charging circuit and a boost circuit, voltage booster. So the LiPo battery, which is 3.6 volt nominal voltage, will be boosted to 9 volts. This is what you see here. I did modify this. So here you see this is the original port where the USB charger would be. And I changed it and I put it here. So I had to open a device and change a bit the thing, put a bit of epoxy. What this allowed me to do is put a hole in the case, and ta-da! I can charge the battery without having to unscrew all the time, which is a huge advantage. Also because these batteries, so multimeters don't show a lot of power. Normal 9-volt batteries last a couple of years. This doesn't last a couple of years. This lasts less than. There's not a lot of energy inside here because, well, they need to put the circuit for the charging, the boosting, and they want to get the cheapest LiPo battery inside it and the smallest one they can get. So here it's written 1,000 milliamperes. No, okay. Here it's written 1,000 milliamperes. I'm sure inside here there's a 100 milliampere battery. It's not more than that, so I'm sure they're cheap. Well, like always, like in batteries nowadays, you cannot trust at all the writing, except if it's from a reputable brand. Even then, by default, I don't believe on what's written here. There's not a 1,000 milliampere battery, something like 100 milliampere. So this is why there's not a lot of energy inside here. And recharging is okay. So whenever I switch it off, switch it on and forget to switch it on, after one day the battery is drained, but I can still recharge it. Now what is important though is that I cannot use it, or I shouldn't recharge it while I'm using it, because the minus of the 9-volt battery is connected to the COM here. An advantage of having handheld multimeters is that it is floating inputs. So these are floating whenever you have a battery, meaning that you can connect this to any point you want. You can connect it to live, to neutral, to plus 5 volt of your circuits, and then you can measure somewhere else. Now, if I have a circuit which I want to measure, which is connected over USB, and I charge this one over USB, then I must use the COM lead to the minus. If I connect it somewhere else, I could create a short. That's a disadvantage for this thing. But just remember, don't use it whenever you're charging it. You're only charging it, or if you're using it whenever you charge it, be sure that the ground is the correct ground. And I want to change this. So if I want a bench multimeter, so another bench multimeter, I have to switch cameras. What I can use also as bench multimeter is we can get the camera where it needs to be here. These are not really bench multimeters, but these are power supplies, and you can use them as voltage meters. So whenever you connect the leads to the board, it can still display the voltage. It is not high accuracy, it is not high resolution, but it can be used as multimeter. Another thing which I've added, which is not there in the beginning, is a switch to either have it completely floating. On this side we have digital ground or a separated ground, and up on the right side I have earth ground. So meaning that if I connect this somewhere, this will be earth. This is mostly important because here the oscilloscope on top, the ground pin is actually earth, protective earth. So whenever I do this, I also earth this minus. So whenever I use a multimeter in a circuit, I do power the circuit, and I power the circuit with the power supply. I switch to ground, earth, and this way when I connect the multimeter lead to the board is already referenced to ground, and there will be no current pathing there, because I had one case where blew electronics simply because I had two different grounds. When I switched to ground not connected, so a floating ground, I had a circuit with the floating ground for the multimeter, and then I connected some other ground, not the oscilloscope, but from another device, a USB device, a monitor which had a faulty power supply. It dumped a lot of current through the ground and it blew up the chip because it tried to equalize the grounds. And this way, if I put to earth, I don't have these issues anymore. So this could be used also at somehow bench multimeter, but not perfect. And why? Switch the camera back. Up. And now I want this one to be a bench multimeter. So why bench? I've explained that I really like it because it has a high resolution, but it doesn't switch off. So when I forget to switch it off, I have to recharge it before I can reuse it, which is kind of a pain. And this is why I don't use it, although it's very nice. And I will change it, and I will simply transform this into a bench multimeter. With what I made is bench multimeter, it will be fixed somewhere, and I will have all the time power going in. You can still use it with a battery, but I have a constant power supply with that. And we will try to see how we transform it. I also thought about taking all the parts inside and creating a case around it, but it's too much work and it's not a lot better because it has one circuit with the screen being fixed in. Actually, what can I do that? It has backlight, I think. It doesn't have backlight. Does it hold peak? No, I think this one doesn't have backlight. This is just to select. Yeah, that's a shame. Bench multimeter could be nice to have backlight. And this one has light. Yes, this one has backlight. Does it do a lot? Hold and it's not. It's very dim. So what I thought before. The thought I had is just take this one apart and reshuffle it and have the screen aligned horizontally or vertically, whatever you need, this way. But the screen is the PCB for the screen with the zebra strip is the same as the PCB having the rain switch, and you can just not change the rain switch because it uses the traces on the board, the large traces and the contact on the board. So you cannot just somehow remove the button, put it somewhere else, remove the screen, rotate it, have the plugs also on a separate side. So I will not modify this and put it in a new case. What I could do is just get rid of the screen. That's possible, and then have some extension leads going there, and then where I can plug some extension lead, and the screen can be separate because here I have an output and a constant output, and I could just read the readings from here and display it on an LCD. But then I have to create firmware which reads it, controls the LCD, shows it on the LCD. And the advantage of this screen is it's good, it's large, it's meant for this. It is really easy to see. I don't have to design everything because the layout is there. The digits are really big. If you put an LCD screen, either you need a huge LCD screen and the contrast is not as high, or you could take a smaller one and you don't have a good reading. So I'll just use it as it. And the transformation I will do is change this battery so I can power it all the time. So it will have constant power, but it doesn't. But this lead or the minus will not be connected. And for that, what I will use is something. Now let's get to parts. There are not a lot of parts which we need. Voltage regulator. So this is my voltage regulator box. We have plenty of voltage regulators. We need 9 volts. We will test how far low we can go, but I think it doesn't operate with 5 volts, or it will complain with 5 volts. We will see. And I will just take a voltage booster circuit which boosts 5 volts, which you see from the inside, to anything else. Up. So we have a voltage regulator. But we can also test if it actually works under 5 volts, or how much current it draws. So this is the voltage regulator, which will boost it will have a micro USB input like here, and from micro USB we need 9 volts. This is why we have this voltage booster. This is the one part. The next parts, which, well, I don't know where it is though. It is in voltage regulator. Maybe it is, because I don't use this part very often. I think I have one still, but in which bin could I have added it? It's not in this voltage regulator. I don't expect it to be in battery management. I have voltage regulators here. Another voltage regulator box. I hope it is inside here. So these are scrapped voltage regulators and other parts. I'm pretty sure I had one. Additional one. And I'll tell you what it is once I find it, if I find it. But it doesn't seem to be here. If it's not in the voltage regulator box, and it's not in the other voltage regulator box, where is it? Oh, is it this one? What is this? Oh, this one is salvage. I don't know what it is though. I'll put it aside because this looks like a transformer. On 3105. What is this? On 3105. I don't know why it switched to something else. But here we are back. So I need to find my part, because if I don't find my parts, it will not work. I can salvage one because I know where I can find one, but I'm pretty sure I had a second one. I didn't buy just one. Normally I put everything here in front. For quick buck boost, but it's not written on the front. And I don't see the part here. Should have checked before. Open is taking place. So, in what other box could it be if it's not in here? Mask sensor, no. Power resistor, no. RF probe, no. Maybe in the back. Temperature sensor, GPS, red spring, capacitors, power. If it's not here, this is another voltage regulator box, but these are also only SMD parts. No, it looks like this, but this is not it. What is this? It does not look like this. Damn it, I don't have it. That's weird. I should have checked if I have it before I started the stream. But I was pretty sure I had one. And I will tell you once I find it. Transistor driver fuse holder, maybe here. Who knows? I'm desperate now, so I'm trying all the boxes, and I will verify in all the boxes a second time to be sure that I didn't miss it. It's not this, so these are mostly drivers. I do also have, actually normally most of the parts have been opto-isolator. What is this? Triac, opto-isolator, and a back. These are motor drivers. These are, I don't know what these are, transistors, 27000. A dimmer, voltage regulators, so it's not in here. I do have an inventory sheet. I will have to look in the inventory sheet if it's there. So, where's my inventory? I'll show it to you. Looks like this. Oh, yes, something up. Something is set parts. Yeah, all parts. Now, category, we have normally a voltage regulator. Let's keep relay. I could put it in relay, although it's not one. Module, maybe it's a module. It's not an inductor. Hub, let's keep all of them. FOMO, no. Texas Instrument voltage regulator. Buck boost, that's not it. Transistor, triac, relay mechanical, no, this is not it. Relay, transistor, switch, relay. Okay, it's not here. I'll show you somewhere else because I know I have it. Because I have it here. What you don't see, but I'm under the table. I'm really surprised that I didn't find our phone. That's the wrong one. App, I can't show you what's under my bench, but it's just a hub. USB hub for here. This up. I already built a cable with it, and I'll explain why actually. Let me get this part, and why I know about this part, which I didn't know previously. So the part which you see in here, this is an ice. I'll open it because you probably need to see what's inside, and I'll show you what's inside. And behind this shrink tube. Whew, I did quite some good work. Large shrink tube, and even the cables are protected. So the issue, what did I use? Yeah, let me first get rid of this thing so we can see what's inside. There it is. So the writing up. Here writing on the back isn't important. This writing is important. B0505S. I can check in my parts bin actually, in my inventory if I have it. Parts B. I have to change the category. Use all categories. Okay. B05. Okay, I don't know why the intermission comes in all the time. Normally it's just a button press, but I didn't press any button. So, I don't know how far I got. Maybe when I was looking in the parts list. So yeah, it is, let me recap because I don't know what I've missed and what I didn't miss. This part here, what you see here, is a transformer, the B0505S, and this transform from 0.5 volts to 0.5 volts, or 5 volt to 5 volt. This is why 0.5 to 0.5, and there is 1 V after it written in the end. That stands for 1 watt. So you can transfer 200 milliamps of current. This is very useful because this transformer, compared to this voltage booster, let's put it on the table. This voltage booster, the ground is the same on the input and the output. Most of the transformers are, or most of the voltage converters. In this voltage converter, whatever is in input minus will also be in output minus. Make a focus on this thing. Okay. And this device here is a transformer where the ground from the input is not tied to the ground from the output. This means that you have a completely floating ground in the on the other side, and this is why we will combine both of the things. We'll have a micro USB connector, micro USB connector going in this transformer with 5 volt going in. There will have 5 volt going out for this transformer. It could be even less than 5 volt because this is a voltage booster. We don't really care. As long as it is under 9 volt, it's good enough. And then this voltage booster will convert it to the 9 volt required by the multimeter. Now, why did I have it? Why did I have it in this cable? Or why did I have it here? This cable. This cable is connected to this thing. This is the stand for the my home phone, home phone. So this is a wireless home phone. It uses the DEC technology. This is just a charging stand. And not only the charging stand, that's the point. It is also the one which is transmitting DEC. So this is the base station. The problem I had is that I wanted to charge it over USB. I don't want to have yet another brick on my power strip because they take a lot of space. And here it says 6 volts input, but you can actually and 300 milliamperes. What I wanted is to power it over USB. I've tested, you can actually charge with less than 6 volts. You can charge it with 5 volts. So I connected it over USB. And the problem is that by doing this in the beginning, I connected the ground from USB from my strip with lots of USB ports just meant for charging, which is under the table, which you don't see. Then this ground is connected here, and here this ground was connected to one of the lights of the phone. The one of the lines of the phone on the other side was connected on the modem to another ground, which is to another potential. I don't know exactly which one. I didn't test it. The issue is when I did this, it was impossible to phone because somehow there was a ground loop or any other voltage loop, and it was just shorting the phone line. So I wasn't able to phone. The solution I did is add this transformer, and this way we get rid of the ground loop because this is completely floating afterwards thanks to this transformer, meaning that pins here can actually be at any potential. I think this issue was more on the modem side, but this was the router which has been provided, so I will not modify the router. And I don't know why in the router they didn't have any galvanic isolation or something like that, because I think it's mandatory. I don't know. I don't know the phone laws. At least I know that I had the issue with the problem is that it was putting these lines at a certain potential, and if I connected it to the ground from the charger, it wouldn't work anymore. This is why I created this cable, and this is how I also discovered about these small transformers. And we will also reuse this small transformer in our multimeter and in our station. In this way, we can actually have this multimeter always connected to the USB or to USB without having problem on the ground lead, because this chip will take care of completely isolating it electrically. We'll have a look at the data sheet because I need the pinout, although I have a pretty good guess at what it is. I need to be certain. Yeah, save. It's a generic mod. Sheet. This is the data sheet. You see 1 watt fixed input, isolated and unregulated single outputs, dip package. So yeah, 5 volt input, 5 volt output, 80% efficiency. I don't really care. The important now is the pinouts, which F9 is the pinouts. So we have pin 1 ground, pin 2 voltage in, pin 3 0 volt, which is not ground anymore. This is why they separated. Then pin 4 VO, because this is the same package for a lot of different devices or for a lot of transformers. Here you can see the part numbering. 0505 stands for 5 volt input, 5 volt output, but you have plenty of other 03, 03, 03, 05, and so on. And it's generally always 1 watt. Now we will measure if it's really 1 watt we need, and we can have a summary of what happened. Presented collection of multimeters. Will use UT61A as bench multimeter. Does not switch off after X minutes. Used USB rechargeable 9 volt battery. That's what rechargeable. Wrong thing. Rechargeable 9 volt battery. And the issue is that ground of charger is of multimeter. That's our issue. Issue up. So we will fix it, separating it. Solution. Use isolation transformer. Isolation transformer. I don't know if I use the name, but this is the package is an isolation transformer. Okay, so this is the start. Well, we have all these parts, almost all these parts. There's one part which we are still missing, and this is the connection to the meter actually, and for that here I have my barrel jack box, and inside here I should have plenty. I do have these things. So these are meant for, I do have one here maybe, yeah. These barrel jacks, these are the most common barrel jack which you know. I'll show it here. Outer diameter is 5.5 millimeter, inner diameter is either 2.1 or 2.5 millimeters. You find both configuration. These are very, very popular, and you find it for everything. For example, you find it on this Arduino. This is the voltage input. You can provide 5 volts, but actually the voltage regulator could also use 9 volt, although it is very inefficient because it uses a low dropout. So anything which you don't use in voltage gets burned. This is why they also provide these leads, and this allows you to easily power your Arduino and have it operating with a 9 volt battery in case you don't have a 5 volt power bank, because 5 volt power banks were not really popular in the beginning. This is where I get these adapters, but what I get them for is for this plug, because it is used absolutely everywhere. And when I build these plugs, when I build cables or things which are dedicated, I use these plugs. But now what we will do is use the other side. We will use the 9 volt battery here to actually connect to the 9 volt battery in the multimeter, because the advantage of the 9 volt battery is that both sides are the same. Compared to other batteries, meaning that you can put it, normally you can put it this way, but if you look at the connector, they are exactly the same, they are swappable. So although this is meant to have a battery connected on top of it, this will emulate the battery up in the power supply right here. And we will connect it this way. Plus, I think the plus is always the small one. Yeah, this is a bit confusing. The plus, I found it a bit confusing. The plus is always the one which is less big. So it's something which is plus, but it is smaller. Probably because plus is then bigger here. I don't know exactly why they decided to do this, but that's how they did it. Now, we have these things. What I'm thinking of is, what will I do? I need also a case. These are almost all the electronic parts. What we also need is, just before we build it, is measure if this will actually work. So let's put this thing on the side. This I don't need anymore. Also, this is done, and everything on my left side is things I don't need anymore, and which needs to be placed in the places at the end of the day. What we need also is a case. So here we already have the hole for the 5 volts, and this is how I'll provide it. We need a case. I could reuse this case because the 5 volt is already in there. It has a charging. I think I will just reuse this case, and this will not be operated using the battery anymore, but I don't care. And to have enough, you see, okay, I now remember. So this is how it went inside, and you see I've changed it a bit. I changed the layout, and can I plug? And you see, here's the battery. This part here is just foam. So they even, normally it has a larger battery. I think this is just a 100 milliampere battery instead of 1,000. Then they added foam. Can I remove the battery? Oh, is the USB really stuck? I think I've stuck it in place so it doesn't move anymore. It would be nice to be able to. We can actually keep the charging circuit and the voltage booster because it's already in here, and then this will allow us to actually have a tiny battery. What we need for sure is separating the 5-volt input. Well, I think I will reuse this case instead of building a new one or 3D printing it. But I need to be able to get the device out. Things you don't see, which only I can see, which is probably not pleasant for you. So, I'm trying to get this battery out. I think it is stuck here. I've added a bit of glue, I think. Yeah, I've added a lot of glue here so it holds well and you can plug and unplug without breaking, because the battery connection is not meant to be on the other side, the PCB. I'll show it to you once I've opened it. This, okay. You see the hack? So, you see, they could add a larger battery, but they tried to skimp and just added foam to fill inside, and it doesn't rattle, and the battery is really teeny tiny. And you see here, 230 milliamp. You don't see it. 230 milliamps. So it's far from the 1000 milliamps which are advertised. 230, I think it's still more than I expected. I thought they would use even smaller. I didn't find where I can enable the autofocus, which is on all the time. This is kind of a pain. I would like to autofocus this camera to autofocus, even if it's not recording, and just streaming. So we've gained some space, probably enough space to actually, and now we don't need to use this voltage booster because this already has a teeny tiny voltage booster on top of it. And this is polyamide tape, which I've added to protect the circuit. We can still use it, leave it here. And you see the blob again. You see that the circuit, the USB connector has been mounted on this side, but it wasn't meant at all to be mounted on this side. It is meant to be mounted horizontally with the plane. So I added epoxy, and we even see the 2 wires right there. And I need the 2 wires to go in here. And will everything fit? So we don't need the voltage boost anymore because we already have here. What I wanted to do is actually just reuse the case, have the voltage booster here, and have my own circuit, and then have a connection. But I will reuse the battery and fit everything inside here because there's enough space thanks to the smaller battery. So let's remove this part of the tape. Battery plus, battery minus, but they've added it. It's also on the front. This is the output. Weird. They have an output in the front and in the back. Well, so you can have it on both sides. Why not? So we have a battery. We don't need to measure how much it consumes, but I'm still interested to see how much when it beeps. When the multimeter says there's no energy anymore, we will still try it out. So I'll try it out now, although this is just out of curiosity because we don't need it anymore. What we will do is use here this bench power supply. This is, so we have power off, this is minus, this is plus. Let me switch the camera so you see what I'm doing. Up. Yes, now you see here. So here we have the bench multimeter, and here we have the oscilloscope, and I could zoom in. And we can test how much it draws. It is connected on the back. So voltage. Voltage. The button doesn't work anymore. Okay. It is locked. How did I lock it? How do you lock this device? I know why it is locked. Let's unlock it. I think I know how it is locked. What I did is, actually we can try it out. So the data sheet, we don't need it anymore. Okay, this is getting annoying. Yeah. Okay. Let's do it this way. Here you see the phone. So the power supply here on the side can be connected to over Bluetooth or USB. I've added a small module inside, so by default it is over Bluetooth, but I've changed it so it's also over USB, and on the back of this DPS power supply, I can switch between Bluetooth and USB. Now it's over Bluetooth, meaning I can use a phone to actually switch it on and off. Does it work? Switch on. Yes, it works. Switch off. And I think this is why there was a lock, because of that. And you can see in real time the screen of my phone. Does it work? Yes, I can see I switch it on and off. So let's change the voltage. How does this work though? Set 9 volts, maximum of 500 milliamp, that's fine. Set, so this is set 9 volts, and it is outputting 9 volts. And it is, it's not drawing a lot, it's not drawing less than 1 milliamp. Okay, it's a multimeter. It is not meant to draw a lot of power, so this is why such a small battery can also last for a long time. But I expected more than just 1 milliamp. Now I want to find out the voltage at which it tells that the battery is not good enough, just out of curiosity. But less than 1 microamp is really not a lot. So we are going down with the voltage. Oh, it's not, okay. You cannot do it live. That's a pain. Okay, I don't like it. I will do it by hand. So let's switch this off. Up. And we will do it by hand. So now Bluetooth is off, it shouldn't be connected, and here we see that the lock is off, so I can do it by hand. And by hand, I can actually change the voltage. I could put it so you can see 9.6. Up. Now we will go down and see when the multimeter starts to complain. Because as soon as it starts to complain, it means it is not able to measure correctly. Or it shouldn't be. Normally it's there to tell that the battery is almost empty, but when the battery is almost empty, normally it shouldn't be able to measure correctly. 5 volt, and it doesn't complain. So we could actually just connect it to 5 volt without having any voltage booster. That's surprising. Although, it does tell battery. Sorry, you don't see it. Now you see battery. So 5 volt is not enough. So let's go up again. Here. 5.6, 5.7. Yeah, 5.5. Everything which is under 5.5 volt is indicated that there is an issue with the measurements, but what we can do is, does it actually change the measurement? Again, this is out of curiosity just for myself, although we really don't need it because we will have a battery and there will be a voltage booster. We will try with a voltage reference. So this here has a fixed voltage reference. I don't know exactly which one, and then there are multipliers, and on the back I can switch between 2.5 volt, 5 volt, sorry, 2.5 volts, 5 volts, 7.5 and 10 volts. And normally voltage standards are very expensive, and this wasn't too expensive though. And the one who tested it had tested it using a calibrated device and put the voltage which he measured. And I don't know what the feed should be here. And on this output we have calibrated. We know what value should be output. And the design of this thing is that the voltage reference here, this is not a cheap Chinese clone voltage reference, it's just a normal voltage reference, and then the circuit with there just to multiply it. So it's a fine device. So now it is on at 2.5 volts. We will put it to 5 volts and we will see if it changes the measurements when the device is increasing or decreasing. And to not be having issue with the probes, we will use leads. So I'll remove these leads. This will be voltage plus. We don't care if it starts, which one we connect first. Voltage minus. The camera a tiny bit so you see what I'm doing. Yeah. Lead to minus. Lead to plus. This should be 5 volts and we're almost at 5 volts. It should be 4.997. This is what the measured has been calibrated, and here it's 4.994. So the last digit is not very accurate. It's not the right one. It's just a couple of digits off, but I'm sure it is plenty within the margin of the specification. Now let's change the voltage and see if it changes the measurements, because here we are on the voltage and it tells that the battery is almost dead. Let's so if we give 9 volts, does it change the measurement? No. Here we have a 9 volts again. Measurement is the same. And if we go down, here we are approaching the mark where it tells that it's not good anymore. Yeah, tells that it's not good anymore. The voltage is although the battery indicates that there's an issue, the multimeter tells the battery is almost dead. The measurements are still good. Now we decrease the voltage and see at some point there should be some interference, or at least it should switch off. 5 volts. So we are under 5 volts. So what we could actually do, what we want to do, is just have the 5 volts directly connected through the transformer isolator to the pins here. We see it works plenty enough, and this battery indication could actually tell us that we are in bench multimeter mode. We'll do it the proper way though, with the battery, because maybe there are other functions which don't work well. The voltage measurement works well, maybe the resistance measurements or providing voltage to the LEDs doesn't work that well if we are under 5 volts. But here we continue, 5.6, 5.5 volts. It's still on and the measurements are still very good. 4.1, still rocking. 4.0, quite good. I didn't expect here. 3.7, 3.8, 3.7. It is still on, still only drawing only 1 milliamp, and it is working. I'm not sure if they use a LDO on the input. We're at 3 volts, and at 3 volts the device still works, and the measurement didn't change. So what we could even just connect. So you don't even need a voltage booster like this. You could connect theoretically on this multimeter. You could connect a lithium polymer battery directly, which is between which has nominal voltage of 3.7 volts and goes up to 4.2 volts. And it seems it would be fine. It didn't test the other modes, but for that it seems to be perfectly fine. Now we're at 4.43, although we used to be at 4.44 or 4.45, and we see that we are flaking. So at under 3 volts, it seems to make some errors. Maybe also this thing got warm and the device changed, but we will see it once we switch on again. No, we see it goes down again, and I think it goes down at this rate, I think because of the voltage input. So this is why it is important that you have, when it indicates the battery is almost dead, change the battery, because your reading will be wrong. Although here it is not terribly wrong. Yeah, we see when I go down with the voltage, the measurement goes also down, but it still operates. We are 2.1 volts, and still the multimeter is still operating and not drawing only 1 milliamp. Okay, that's surprising. Oh. Someone writes. Thanks. Feedback from a viewer, I think. I will reply to the chats. It will. Was it not? Up. Okay, so let's continue, and we see we are at 2 volts, and still the multimeter is working, which is very surprising. I still want to figure out what is its cutoff voltage, and we see the measurements are wrong, but here we continue to go down. The measurements always go wrong, but 1.8 volt, it still operates. Okay, 1.6 volts. At 1.6 volts, it shuts off. It is quite surprising. If I go up again, it switches. So 1.6 volt, it shuts off. There's a brownout, and then to switch back on, we need 2 volts. At 2 volts, it switched back on. The measurements are still not very good at 2 volts. And if we go back to the 9 volts, if we go everything which is above 3 volts, the measurements are good enough. Yeah, although no, yeah, above 3 volts, it seems plenty enough. But to be sure, above 3.5 volts, the measurements are good. It still indicates the battery is wrong. I don't know again if in the other modes it works. It works well, but for voltage it works good enough. So you could actually directly plug it to USB. We will still use the battery as kind of a buffer, and to have the voltage booster to boost it to 9 volts, so it is in the specified voltage range. But we know it needs at least 2 volts to operate. It needs at least 3 volts to have good measurements, and it only draws 1 milliamp. That's about this multimeter. Every other multimeter should have their own specification, but I'm surprised. And it's only 1 milliamp when we are in voltage mode. I don't know if in other voltages, it's all the devices, it's the same thing. So if we use this device here, this, it doesn't focus on it. Okay, if we use this isolation transformer, then we will have plenty of power, because it is for 1 watt, meaning we can put out to 200 milliamps. This uses 1 milliamp. I'm interested to test in the voltage in the. Now I'm intrigued in the if it draws more in the older modes. For example, if we go into the home mode, if I measure a short, okay, it doesn't draw more. It draws more. We see we are here in the resistance mode to measure the resistance of devices and resistance. We are at 3 milliamp. And what I'm interested is probably the mode which draws most of the. Let's go to milliamp mode. Okay, it doesn't draw a lot. Amp mode doesn't draw, but the one which probably takes most energy is either the capacitance mode because it needs to charge a capacitor. Yeah, 3 milliamp. Or the beep mode, continuity. Let's go beep mode. Yeah, when it beeps, it draws 5 milliamps. And the LED mode. So let's go to the LED mode and test. Let's get an LED. There are plenty of LEDs around here. Oh, sorry. One of my tiny LED boxes with a lot of colored LEDs. We'll just take one LED and check. So the long lead should be the plus. The short lead should be the minus. And up here it uses 2 milliamps for at least this one. So yeah, it doesn't draw anything. We didn't see it draw anything which is over 5 milliamps. A comment. Nope, it was just also very good visuals. Thanks for the visuals. Yes, the comments. I disabled the YouTube comments because I didn't find them useful. I don't want to manage them. I think they take a lot of time to review. Still, you can. It's really easy to go. There is a link to the original post on the website. There you can put comments without subscribing, without signing in, without putting an email address. You don't have to put anything like that, and you can put a comment. So if you want to put a comment, you can put there. And also it discriminates. So most of the YouTube comments, why I don't enable them is telling how great it was. I'm not interested to see how great the thing is because I'm not doing the videos for YouTubers. I'm doing it for myself as documentation for final projects or closing documentation for projects. This is why I'm not interested to have people say how good it is. I'm more interested to say if there's a mistake. There was a mistake in the video, which I fixed it. There is still one mistake in the video, in the YouTube video, which I cannot change because I cannot re-upload the video. But I've added a comment at least for this mistake. On my website, I can't change my videos. And on my website, there are the comments. And disabling the YouTube comments also kind of puts a barrier meaning that someone who really wants to put a comment and say something just of showing how good it is will have to be forced to go to their website, click on one link, click on one other button to say comments, and then send the comment. But just going to another website already puts kind of a barrier. So yeah, I am pretty I'm aware of this barrier, but it also allows me to filter out all the comments which are too simple, in which I'm not interested in saying how good it is. I'm more interested to find errors, how bad it is, how I could improve, things like that. This is a lot more useful though. But still, I'm happy that you liked it. And I will still continue to disable the comments. But now you can tell me everything in the chat, and I have no other choice than to read them and reply. Unless the chat is overcrowded, but I'm not sure this will ever happen. So for now, I can chat with you, and thanks for the cheers. Back to the projects. So we will switch camera because we don't need to see the power supply anymore. We can switch this off, multimeter off. We will switch to the main camera. We've tested that we could actually power it directly with 5 volts, but we will not. We will still use the battery. This will kind of act as a buffer, and the advantage of using the battery will be that although this will be a bench multimeter, I can still unplug it, not change the battery, and use it as a portable handheld multimeter and take it anywhere I would like to. Which is another kind of advantage. We just need to now figure this out. I will tap on these cables. Wow, they're very short and they're very fine. Sorry. Here there are two cables, plus and minus, from this USB plug, and I need to tap here, and there in this clear plastic here is 2-part epoxy, and I've added it because whenever you plug something in, there will be a lot of force applied. I've even added lots of glue to actually hold it correctly in whenever you press on top of it. So I will have to remove the hot glue. And to remove the hot glue, actually there's a really simple and nice trick. You have to start focusing. There's a really simple and nice trick, which is using alcohol. So here I have a tiny bottle of IPA isopropyl alcohol, just pure alcohol. You just put plenty of it, and hot glue, I don't know why, but hot glue after some times just gets easy to peel off once you've added alcohol and waited a bit. So let's take some tweezers, and I think I will have more issues going inside the device than removing the So let's test it out. See? It already debonds. You don't see it here. It already debonds from the material. The alcohol was not good for static mat. So let's put something in the middle so there's not too much of it. Okay, the first part is removed, and I'm almost done. Push it out, up, and you have it. This is the hot glue which was supporting the material, and you see it just, although it was glued on, thanks to the alcohol, it just gets easy to remove. So small trick if you want to get rid. I love hot glue because it's really simple to use, it's really cheap, and it's also really easy to remove. Now, we will not have it as easy for this device because this is not hot glue, this is 2-part epoxy, so it is very hard plastic. I will have to scrape it off, except, yes, I do. I will have to scrape it off. Now I want to check if I have space. Where will I put the device? So there's plenty of space on this side. This is why they added the foam. And is there enough space to actually fit this thing? Battery. I need to put it somewhere. I could put it to the side actually, because the battery doesn't use the side. This board also doesn't use the side. Here we have some space on the side. Yeah, I think this it does put pressure on the battery and on the board, so yeah, it has to be flat. Somewhere where they're not high components too. They're all very high. Let's try it just here. Maybe I'll have to squeeze it in. Oh, it fits perfectly, even with the thing inside. So now it's that. Actually, I'm kind of happy that they're put foam and a small battery, because now I can actually feed my isolation transformer. And that's almost it. It was a lot simpler than I expected. But we still need to have access to the cables here, so we can use, so I can put the isolation transformer in between. So, two solutions. Either I break off completely the USB and I put a new one, a USB connector, or, and I think I will use this one, I will scrape the plastic with a cutter and have access to the wires, because it took me a really long time to have the connector fit well, so it does take time. So what we will do is scrape here the plastic, so we can have access to the two pieces. We can actually, I will scrape it off from the USB connector, so we can have wires directly from the USB connector here, and then the two other wires, which are probably not long enough, which we'll have to extend to the other place. We'll put this way. Up. So. Still not happy about the solution. Yeah, but we'll do it this way. I think completely removing the connector and putting a new one properly will damage the board a bit too much, and I don't want to spend too much time on the board, so we'll just scrape it, try to have access to this cable. Without cutting the cable. It very gently. We are near the cables now. Almost there. I could actually just, but I don't have a view with just, because you don't actually need to see, you don't actually need to see everything. Can I switch? Does this full screen project lock enabled view? Let me, okay, I'll just put this in full screen. Up. The rest is not really interesting for now. So this way you see a bit better what I'm doing with the higher resolution. I can, probably if I go too low, it cannot focus because the lens, I will have to use a macro lens. And when I move, you don't see anything anymore. Now I'm just removing plastic. The epoxy is not as hard as I expected though. It is not too brittle. It is. Don't remove too much because we still need the strength of the USB. Is it exposed enough? It needs to be exposed, and I need to be able to cut them and to interpose my isolation transformer. Not sure if there's a good trick for removing epoxy except completely burning it, like I showed in the video. I just think for now stripping it this way is fine. Okay, here we have here. Can be fine cables. I mean, the charging doesn't need to be very fast. It will be constantly plugged in. Maybe the battery will blow up after some time. It's a very common mistake which you see in laptops or phones less, because you never leave them plugged in all the time. But when I did test benches with plenty of phones which were performing tests and network checks all the time, after a year or two the battery starts to blow out and starts to get thick. You find it most often in laptops. Whenever you use the laptop as a bench computer or as a table computer and leave it charging all the time, then the battery will blow up. And this happens to all batteries. This is completely normal. It's just that this top up all the time makes the material inside it gas, and this makes blows up. It happens really to all batteries. I've seen it also in plenty of MacBooks actually. And problem is, in MacBooks it is really tied into a tiny space, so it cannot blow up without deforming the PCB. It's not a good thing. It happens to any battery. So I have access to the cables, kind of. This one for sure. This one almost. We can still test if I did cut the cable, because if I plug it in, it should light up blue when it's charging and red when it's not charging. So up, yeah, red meaning the battery is not charged and it is getting charged. So the USB still works. Let me check it with my eye. With the camera it's not easy to see. I said I'm starting to scrape the copper. And you can see it very well because of the high glossiness, but yeah, there's one copper path. This here is where the other copper path is, the bit shiny part. This is the exposed copper I've started cutting. I need to get this camera a bit above because I don't see anything myself. So let's try to remove a bit of plastic underneath it. I will need to cut the wire, so it's not too much of an issue if I do cut it by accident. This one is will be really easy. I'm really right under the left wire. This one won't be hard to get. The other wire though is a bit harder because I'm not underneath it. Ideally it would be between the pad and the wire, but it's too far below. Maybe with the soldering iron, whenever I will get near to it, the epoxy will also start to melt and free the thing. Let's try it out though. Is epoxy, this two-part epoxy, is it immune against heat or will it deform it? Let's try that out. So, let me switch on power supply, soldering iron. Switch the tip and have a finer tip. I don't want to damage my tip though. This one is okay. Up. Bit of water. You don't see anything because I've removed the overview. So we'll try with this fine tip to see if plastic melts. We are at 380 degrees. No. Not at all. Not at 380. Let me check if this is really 380 by just melting some solder. Yes, it is. It is warm. But it can go up. Let's go to 450. 450 settles. Now it starts to a tiny bit. But now the epoxy is still has the force. And it doesn't burn even at 450 degrees C. Celsius, because I'm in Europe. Oh, it does start to melt a bit. It makes it brittle actually. That's surprising. It doesn't melt it, but it makes it brittle. I didn't expect that. Yeah, it makes it brittle. And because now I lean next to the wire, you don't see it because I cannot see it good enough through the camera. Okay, that's one wire treed. And okay, here we have 2 free wires. I'm not sure if the macro lens here is good enough so I can show you the details. I will try though. The bench is getting to be crowded. So, where's the focus button? Here's the focus button. Does it work for the... I have moved completely the zoom. What did I do? You see... Where's my cutter? It's not the cutter, that's the cutter. Try to do it under the camera. See here, this wire. This is floating, this I will cut. And on the other side, this is the floating wire going through the board. And here we have the contact pin to the micro USB port, which I will try to solder on again. Tiny wire. So let's solder tiny wires. And for tiny wire, I will just use 0.2 millimeter. 0.2 millimeter wire. Plenty enough for the current we are carrying even 0.1 millimeter should be plenty enough. Oh, my other soldering iron, the one to actually solder and not scrape plastic. Will it solder? I will cut the cable afterwards. For now, I'm trying to solder the wires where they need to be. I can still shorten them afterwards. And this is coated wire, so we will need to pre-tin it first at the end, else it will not solder to anything. Is it coated? I don't see it. Okay, now the coating is there. It is really small. Okay, we have one wire. This is the wire going. I never know if it's plus or minus. This is a pain always. Mine USB, I don't know if the right one is plus or minus. We will be able to measure it, but let me check. It is this way. This is plus. As far as I remember, this is plus. So, cut the wire. It's too long, but it is long. We don't care. And now put the other wire to the USB connector. Okay, coating has been removed. I'm trying to add some solder to the USB pad. Does it work? Or do I need to scrape more off? I don't know. I think I need to scrape a bit more. As I don't feel the hard the hard metal. I use this other soldering iron to make it brittle. Now I kind of have access to it. Let's see if I can solder the wire to it. Solder. And the pin has been damaged because it's been used for plastic. So yeah, scraping plastic with the soldering pins is not a good idea. Oh, it seems to hold. No, it doesn't. We will add epoxy once we have a good connection. We don't have any connection for now, not even a bad one. Trying to have access to the micro USB pin, but it's covered in epoxy and the solder doesn't get to it. doesn't stick to it. Let's try it again. New solder. Maybe the solder I had on the tip was too consumed. I don't see it by eye though. See, it seems to be there, but with the eye I don't see that it is connected. Not with the camera there. We can still check if it is by plugging USB in. Up. Once we have the other wires, we can check if there's 5 volts going there. The wire too long, I don't care. I will shorten them afterwards. So that was the one side. Let's do the same thing on the other side. This will be easier because it is exposed. Oh. I have the feeling that yes. No. Okay, let's remove this USB connector and put a new one and do it correctly. The cable was not in the USB thing anymore. So, in the end, we spent half an hour trying to scrape off the thing and lost the time, but this is how it always is when building devices. Things don't get as planned. And now I'm trying to get off this connector by scraping the epoxy without breaking the board. Up. The connector is gone. The epoxy is gone. We almost already see the original footprint. These are the finish this. Clean a bit. Oh wow, I don't know. There was no melting point for the USB connector. It was really just held using epoxy. Surprising that it held that well. Maybe it didn't hold that well, but clean off. Using solder to clean the pads. You need to make a focus. I could just I could go into aperture mode. Yeah. Now we have the largest aperture, meaning. But I don't know if this is for live preview. Okay. So the pads are tinned again. This is where the original connector was. Center focus. This is where the original connector was. There's still a bit of epoxy on top of the LED, but I will only make it more diffuse. Up, up, almost all epoxy gone. Okay, so we can put a new connector. We know it should be around somewhere here. The problem will be, again, like the first time, because of the 90 degrees is making it really stable. We will add epoxy, that's for sure. I can switch this off. We'll use epoxy, that's for sure, but I don't know if it will be enough. Well, we'll have no choice. We will test it. So, we need a USB. USB, I have USB connectors. Here. A box with plenty of different USB connectors. And we will have this. So, we see it better here. Plenty of different USB connectors. We will use micro USB. Can I use? Yeah, micro USB. I'll use micro. We could use USB-C. No USB-C. Micro USB. USB-C even is more a pain to solder. We will use this kind of connector, and it's a quite funny micro USB because it has only 2 pins, plus and minus. It doesn't have the data pins, so it's really meant for powering devices, and it's good enough. And the advantage here is that the pins are really far outside, so we can easily tap or solder on the USB pins. And we will have just wires going to the USB pin. Up. Which we can bend, and then wires going up to here. This will be a lot easier. It's a lot faster also. Up. So, now we don't care what is plus minus. Oh no, we do care what is plus, what is minus. But we can watch it on the board. Still pretty confident that the one on the right is plus. Let's have it not this way, but this way. So, one is soldered, and yes, I think I was right, because the one on the left is connected to this large copper plane, which I expect to be ground. Large copper planes are very often ground. But we will measure it, because I did the mistake too often to rely on assumption. Okay. This way we burn the coating, but we didn't burn the coating. We just burned the flux. Now the coating is burnt. Up. Soldering on a microscope is really not easy, because you don't have a view yourself on the thing. I could use and the resolution of the LCD of the camera is not high enough. I think, yeah, this is a large plane. Up. So we have the 2 wires going to the boards for plus and minus. Where is this device? This will be here. So, USB. Oh. Was it this way? Now I have to check. Okay, so this is minus, so this is plus. Yeah. See, this, focus. This pin is connected to this large copper plane, and this large copper plane is soldered on the wire with this this large copper plane which goes to P minus. So this is ground for sure. So the one on the right is ground, the one on the left is plus. Can already solder them on this small device, which went this way. So I think the output was plus here. This pin 1 is plus. What is it, bottom or top view? I still have the data sheets open on my screen. So data sheet. Bottom view. If we look at the bottom this way, the top left one is ground inputs. The third one is ground outputs. Well, 0 volts. Because it's not ground anymore. 1, 2, this was ground. Yeah. We have long enough cables. Up. This will be. Should I add glue now so it doesn't move? Yeah, I will add glue. Let's remove this wrapping. No, keep it, remove it. The glue will not hold well on it, but up. Yeah, I want to glue it because I don't want to hold it all the time myself. And we will need hot glue in the end. So let's heat up and let's warm. Hot glue gun up, hot glue gun plugged in. Now that you don't have the overview, you don't see it anymore. Can I put it back so you can see the overview? Tuk, 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 tuk. Up. Now you can see the overview again. So here we have the hot glue gun. This is minus, so it will be on the 3rd pin. Plus will be on the 4th pin. No, which is the right order. Seems fine. Now we have to wait until the glue is warm. Oh, there's one tiny bit which is going out already, but it is not warm enough. Let's get one drop just so it holds my part. Okay, the part is held on well enough. We keep the glue gun up and running. Also, you will need it in the end. And I don't want to wait 5 minutes for it to be ready again. So, 1, 2, 3, this is minus. Let's put the wire this way. Solder on it. Can you zoom and still have the focus? That's good enough. Come on. Coating. Burn. Nope. Coating. Now. And we can cut the wire. Up. Clean cuts. Same here. Wrap the thing around. The camera, you don't see the 3D perspective though. So easy for you to watch. We can see that the wire is going there. Now plenty of heat and plenty of solder, so it burns the coating away. No, still not burned. Come on. Now it is. Yes. Yep. Blade is getting dull. So here we have 0 volts and 5 volt output, and I didn't test it though. But I think it's okay. We'll test if it works actually. Using the bench, power supply, set, track, 5 volts input. This should be, let me check a second time. It says bottom view, does it say bottom view? This way, bottom view, the one is ground, yeah, so it should be fine. Here we should have ground. If I enable the output, I have output enabled. If I touch, it should be red saying it's charging. Works! Red charging, and we have a completely isolated 5 volts. And to charge the battery, yeah, we have 200 milliamps. I don't think it draws 200 milliamps. This is a 230 milliamp battery. Generally, you charge it at 1C. If you want an everlasting battery life, it depends on the battery. You can charge it faster, but the rule of thumb is charge it at 1C, meaning that if it's a 230 milliamp hour capacity, you charge it with a current of 200 milliamps maximum when it is in constant current mode. I didn't measure. I didn't measure if it's really this way, and I don't really care if it's under, then you will have less voltage and the thing will be always connected, so I don't expect it to be a problem. We tested it right now. Power is going in. Now we have to do the same thing with this. Should I first fix this device somehow, this USB thing, before soldering? Or should I solder the wire and put lots of glue afterwards? Problem is with adding glue, I have if I put the wires now, it will be very breakable. We'll have to add glue now, and add plenty of glue afterwards. Maybe we can even do that and cheat a bit. Let's try. Yes, a technique I haven't used yet, which we will try out. I will use some kind of metal. I don't want it to be my solder mat. I'll use something. White piece of metal. Here we have a white piece of metal. It will shorten things, but I don't care. We'll add, this will be the final form. What we will do is create a case, kind of a case, for the glue to go in. So let's just fix, using hot glue, but just a tiny bit. Let's fix the circuits down. Since it's just hot glue, it will not hold very strongly, but good enough for now. Then we can remove it afterwards. Cut off this hot glue. Need to fix my tweezers. No, not tweezers. Side cutter. Let me get another side cutter. This one is old. You don't see anything up here. Now I want this to barely be fixed. Good enough for the rest. Glue. Okay. So we added the glue. Now we need to wait until it cools down. Luckily, it is on a metal piece, this metal piece. So it will cool off a bit faster. Prepare the cables. This will be bent. I should have bent it before. I don't want to put stress on it. So, tweezers up. You will hold the USB connector and you will bend it down. I can use it also as fixtures. Up. Holds well. I didn't expect it to hold so well. Up. I did pre-tin a wire here. I will pre-tin also. 1, 2. I see that it makes the spike here, which doesn't look very good. You have a tiny spike on this thing. It means that the solder is too old. And all the flux has been removed. So either you add a bit of flux using a flux pen, or you just use fresh solder. Now it looks better. One wire. Let's cut in half. So we have the second wire. Up. Cut in half. I didn't pre-tin and remove thing on the coating on this wire. And it looks like shit. So let's remove the coating. Damn it. I should tilt the camera so you have a bit angle view. Come on, coating. Burn. Okay, now the coating is burned. Tack. Second in way. Let me try to add a tiny bit of angle so you can see it tiny better what is going on. Oh, yeah. Not a huge angle. but still a bit better. Up. Come on, make focus. Up. Pretend the things on the bottom. So this is plus, so it's right here. Up. Of USB. To pin 2. Come on, coating, burn away. Okay, now it's burned. Let's cut the. But this scalpel, this blade's getting dull. So let's, instead of using this cutter, we will use a scalpel, like a real scalpel. So this is surgical, a surgical scalpel, and the blades are very soft, but they cut very well. Oh, they're very, very sharp. You can cut well with it, but they're also very soft metal. So after a couple of usage, just get rid of this blade. See how well it cuts? Slice through it, although I didn't put a lot of pressure. So yeah, you can actually, you can see here this one with surgical metal, you can just change the blade and don't have to throw away the complete knife. And for things which are really precise, where I don't want to put a lot of effort or don't want to put a lot of stress, I'm using surgical cutters. Surgical cutters? Are they called cutters? I don't know. Surgical knives. And I can recommend them. Oh, I didn't solder the wire enough. I thought it did. Okay. Now it should be enough. Up. Wire cuts. And now, in theory, I would actually test it with the USB connector to see if it works. But since it is fixed on this platform, I cannot. But I'm very confident that I've did good solder here. It looks good. So what we will do is add a first layer of epoxy to somehow hold the connector using this tab to the board, and if it's finished we will add even more epoxy so it goes up to here and holds the device well. We will do a two-stage, two-part epoxy. So epoxy, I use any kind of industrial epoxy, in this case this one, Chinese epoxy, I don't know, it works good enough. I never had an issue with them, though it's very soft. There are plenty of different epoxy types, one which cure fast, one which take a bit longer, and so on. And this is, I think, 10-minute epoxy. Well, 10 minutes until it is strong enough so we can poke at it. But I still leave it 24 hours before I use the device. I don't care which epoxy it is, so it hardens completely. even if it's the fast kind. So we will try the device before the 24 hours. I will not have the stream 24 hours open. So, epoxy, two-part epoxy. You see there are two syringes, two syringes in one, and there are two holes. And if you press, they should flow out at the same rate, but they never do, because if you don't use it at once, everything at once, it starts to harden. So now we have one side which is coming out and the other isn't. For now, because it hardens. It's the pain of having large tank of epoxy. Now the other is coming out, you see? Now somehow the other one takes a bit longer to come out. Now I just wait. So the first one is more liquid, the second one is a bit more solid. And we mix it. And I use a, how are they called? One of these wooden sticks which you use for your teeth normally. Up, let's close the thing again. Tack. Epoxy is closed. This is garbage. Up, this is already hardened epoxy, which I don't want, so we'll put it in the garbage bin. Up, and now we mix. There are plenty of bubbles. It's not perfect. I don't care. It will just be hard plastic. If you think you finished with mixing, do it as long. Take twice the time, so you're sure it's mixed good enough. It's not this couple of seconds which will be an issue. So we will add epoxy. That's too large of a blob. We'll add epoxy inside. It doesn't stick to the board. That's not good, because this is where I have the force. It sticks a bit better to the board now. Up. This epoxy, I need it. This is just the first layer of epoxy, just so it holds good enough so we can test it actually. Stick to the board, else you will break, even if you will have support. And now we have to wait 10 minutes. And there's nothing I can do about it. I cannot speed up time just for that. So the stream will also have to wait 10 minutes. I hope that it didn't get inside the connector. Normally I plug the USB connector inside, so the epoxy doesn't go in and block the way, and I think I have to do that, else I will have issues. So the epoxy is now a tiny bit hard. Yes, it starts getting hard, so it's fast epoxy, fast curing epoxy. So to remove this, same trick. To remove the glue, use alcohol. Alcohol is a solution. I need tweezers here. I didn't put alcohol here. That I did. something bad. It's not cured enough. But I still want to be sure that the USB... Yes, the epoxy is getting inside the USB connector. I want to be sure that it doesn't. So we will add a USB cable. If it's not too late. Fuck, it's too late. No, it's not. Okay. I will try somehow to have it. This is now real pain. Have a stand. So we will have. This is not going well at all. Because the epoxy is not sticking and connector. Fast before the epoxy cures too much and doesn't stick anymore to anything. Up. This way. Now. Epoxy cured a bit too much. So let's try to remove it and put new epoxy. Let's try to remove it while it's still flexible. Okay. Failed again. At least now we can test it with if it works with USB. Okay. Was able to remove a bit of epoxy. The other side too. Okay. Now remove the epoxy from the connector. Sticks well, at least. That's a good sign for the next run. It cures really fast. I didn't remember that this epoxy cured as fast as this one does. I'm a bit surprised. And generally, I think if I want it to cure even faster, I apply heat to it. I'm not sure if it's a good method, if it will destructure it or have it clean fast enough. But yeah, with the hot air gun, I apply heat to the epoxy so it cures faster. Okay, the epoxy is gone. Before we put new one, we can now actually test if this works. So we can plug it to USB, and if it lights up, it works. So here my USB bench power supply, up, and it doesn't light up. because the cable was broken. I'm very barbaric now. Okay, now both. Nah, the plug is completely broken. I have more than one. Oops. Okay, this attempt was unsuccessful with applying the glue, and this is also the longest. What took the longest in the other, the one I had before. The devices was gluing the connector. It still seems to be the same issue, and I need to buy more connectors because I'm running out of them. It seems. Now it is inside. Let's solder the device, the wires again. Let's bend it beforehand. And now we can actually put the complete glue. If we know it works, we can completely fill it with glue, with epoxy. And first we have to test if it works. Pre-tin the pins. One. Two. Now it should work. Let's plug the USB and let's have it shine red. Red. Meaning that this works. So, how will we do this? How will we fix this connector? I would love just plenty of wart glue, but I have to think it's not strong enough. Because that glue is really easy to remove. That's a huge advantage. It's easy to pour. But I would have to put it this way. I need a stand. This is a stand, but it's not a stand high enough. The multimeter, a high enough stand? Yes, it is. Not ideal, and I was. Well, seems okay. Oh, it seems to be. I don't want them to touch each other, although they're coated, there shouldn't be any short. I still don't want them to touch another. Back off. So. Let's try with that glue. I'll see if it works. The stick is always almost gone. Always something. Let's get it. Yep, stick. New stick, and let's try it out. I hope it's warm enough. So it just falls to the bottom. I'll poke with the toothpick, that's the name, to be sure it goes inside. Up, try to focus on this part. So, up. Okay. It's not looking beautiful, but we will cut. We'll cut whatever we don't need. For now, it just has to hold a tiny bit. Enough so we can plug in the connector. And we'll use the same trick as I did before, put a lot of hot glue inside before we insert it, so it tries to stabilize everything. Well, while it cools down, I get something to drink. I'm back, and yeah, looks strong enough. It's not overstress it, but yeah, it's holding the connector quite well. It's a good start. So I want to fix this other thing here. Up. Trying to fix the side cutter because the spring somehow isn't holding well. And since normally it means I get rid of it, all the way around, seems to hold. Let's get rid of the strings. Now, important part is not only plug in, but if I remove the connector very gently, does it break? Does it hold? Holds. Okay. So no epoxy. Hot glue was good enough. Probably because the connector is large, and if I plug it back in, there will be a thing on the back, so it will hold it off. Okay. Seems to hold well enough. Oh, epoxy, not a good idea. Not for this one. Now it's easier to repair. It's even easier to repair. So, let's get rid of this piece of epoxy. Hot glue. Have this tested. Let's plug the USB in. Up, USB. If I switch off, we should see red. Yes, we see red. Means it works. And we have isolated USB. We will test if the USB is re-isolated or not in the end, because who knows if this thing is good enough. Although we can test it now actually. Here we have minus, here we have the, not the minus here, but I need, do I have it here? Up here, this thing here, this thing. Plus the minus, data minus here. We'll use this board. So let's use our second multimeter and test the resistance between the USB inputs and the USB device itself. Well, this thing. So, whoop. Ohms. Focus on something. Here we will test, this is the minus, yeah, because it's larger. This is the minus. Let's test if our probes work and ohm range works. Yes, 0 if I have direct contact. Now I'm on minus. Let's test minus from here. Z output, so there's infinite resistance between the outputs, which makes sense, yes. And if we try with plus, which one is plus? So this is, oh, this is data actually. This was minus. USB, here, USB plus. USB plus is not on any of the connectors. USB minus, any. So we have infinite resistance, so the isolation works. So we have completely now, still have completely isolated multimeter, a battery for the multimeter, so we can keep it charging and keep it powered on all the time, and this makes a kind of a bench multimeter. I can actually switch the screen back on, and this will switch off, power off. Oh, you're still streaming. Shutting down, okay. You got warm, very warm. You will charge. I will close this. Solution, use isolation transformer. Let's update. Let me switch on this again and let's update our status. Reuse rechargeable 9-volt battery. We will reuse this. It provides a case, contacts, and boost converter, voltage booster, or step up. I don't actually know what is between step up voltage converter and boost converter. I don't know the difference. Not too much into analog devices. Replace input USB, insert isolation transformer between input USB and board. This way. This is how far we have been, and now we just need to close it. Let me reply on the chat. Although I said that I said in the stream why I don't have YouTube comments, I will still add it in the chat for the people not wanting to go through the whole stream and only wanted to watch the chats at the end. This is intended. I think it's even written in my FAQ why I don't enable chats. On the main official podcast website. Actually, we can put it, but well, I'll just comment this. It's Up. Okay. This is responded. So now we need to put everything this back in the case. And with plenty of glue, so it backs up, of hot glue, so it backs up this thing and up. And well, let me remove the cable, because if we put it inside, so it backs up the thing, and we can press really hard when we insert the USB connector. Gently. Okay, now it's removed. And does it still fit in? So it should fit inside here. Let's put the battery. Let's put the battery this way. It seems to be a bit more flat on this side where the protection circuit is. It needs to go in this way. Now I remember, because I needed to turn around, so I have the device on the right side. What is plus, what is minus? Where is my case? Here is the case. I don't need the soldering iron on. Let's switch it off. Here's the case. It will go this way. Yep. So this is the right way. Okay. Now we can see the USB is doable here. So now I will fill it with glue. Was I able to close it? Let's try if we can close it. Actually, there is. Oh yes, there is a plastic slot inside where I can insert it. That's useful. And the leads are long enough, so I can put the board without putting the battery in. But the USB connector is a bit, damn it, doesn't want to go in the grooves, because the USB connector is a tiny bit raised, and this tiny bit is enough. Ah no, I know why. Here, because this plastic, this glue is preventing it from sliding in, because it only wants the PCB. That's why it doesn't work. This side is good enough. The other side is not good enough. Let's lose the scalpel, it's already here. The joy of scalpels cuts so good. Actually, it cuts a bit too much. I don't want it to damage the board. Okay. I need to remove a bit more, but this one doesn't cut enough. Okay. Up. Now it goes in well. Can I still slide in the battery? Yes, I can. So I can close it. And actually don't need, I could add glue here, because I broke somehow the case. It was glued in, and it's on the wrong side. So I could add glue to close the case, but when it's inside the chamber, it holds by itself. So I will not add glue here again. I don't remember if it was ultrasonically welded here, or if it was glue. It looks like ultrasonically welded. I don't see a trace of glue. So Now we need to put plenty of thing inside here. How's it called? Hot glue. So it acts as it holds better the USB connector in case of stress. Up. It will come out here, so we will add some tape. We will use some polyamide tape. There's tape, the brown one, which is heat resistant. Let me get some scissors. Up, scissors, tape. This way it will not go outside. And let's fill it with glue. Okay, that should be enough glue. I hope it's not too much and it's warm enough so I can slide in this thing. Up. I need to be able to access the USB connector. Up. Plug in the USB so the glue doesn't go inside. Oh, it's melted. Did it? I have the feeling it melted the plastic. It's not holding back. Did I put too much glue? Or didn't it go in the grooves? No, it didn't go in the grooves. It's so warm that it also melted the other plastic, the other glue. Ah, it's a mess. Now it won't be warm enough for me to slide it correctly. Let's wait a bit. Let's wait until it's clean again. Let's put this inside so it holds. Okay, that was too much glue and it got too warm. And it's a mess inside here. And we have to wait before we can apply the alcohol solution. Does this thing still work? Yes, it does. This still works. Okay. Failed again. Alcohol. Maybe I should just add not too much glue or fill with glue from the other side. We are almost done. That's always the last part which takes longer. Where's the other pair of tweezers? This one is a bit more robust. Okay, now it goes out. Oh yeah, probably I had too much glue inside here. Up. Let's remove this so we have an exhaust port for the glue to go out. We can see even the glue went all the way to this side. Okay, don't add so much glue. Just a tiny bit. Okay, all the glue is removed. Let's try if the secret slides in. I had glued the connector. Glued the cable on the connector. I don't want too much stress on it. Come on. I can't remove the USB connector. I don't want it to wiggle too much, as it will wiggle it from the board. If I just free these parts a tiny bit. Damn it, rock solid. Phew. That was hard. Tape. Oh, it did warm up too much. You see there's a tiny dent here. So don't add too much glue. It will really melt the plastic. Yeah. This, you see the glow effect? Yeah. There was a bit too much glue. So let's try to put the board back again. In the slot. Is it on both sides? Yes. Can I actually fill it from now? That probably won't be enough. Oh, it's liquid. I could actually try to do it to fill it from this way. Okay. Why didn't you hold? Ugh. This is not good. Ah, it's the last mile. The glue is not sticking on the board anymore, so let me reheat it. So it flows back on the board. It holds a tiny bit, at least until I can solder it in place. Let's wait until it cools down again. And I hope it glues a bit better on the board. Waiting. It's not in focus. Right, just the last mile and then this annoying tiny things happen. Okay, good enough. And I think I've added far too much thermal mass last time. Are you slots in both sides? Yes, you are. So you should be able to hold. I'll put the connector now so I can test if it still works. Glue is getting inside the connector. Not a good thing. Ah, it doesn't work anymore. Damn it. Seriously? I broke some cable. Are you serious right now? Or is it just because of the inside? What is happening? Let me test if power is going into the mains. Oh, it's coming out. If it's coming out, means that the tracks on the PCB have an issue. Multimeter. Pin 2, pin 1. Damn it. Power should be on. I can't measure anything. There's no 5-volt output. Oh, there's 5-volt output. Wow, 5.8 even. It's not a 1-to-1. So it means that in the connector there is it means that the tracks. No, it means that there's an issue on the tracks. And the wires are not on the tracks anymore. And yes, I can see it. One wire broke off. Can I get it from here? Where's my fine tweezer? Here. So knitted in and now so far. And yet so far. Can I solder it from here? I don't want to remove everything again. Just one wire. So you'll know it's it on the camera. Let me show you on the camera before I do it. Somehow you can see that one wire, the plus, is not connected anymore. It's really tiny. Wire here. Too much glue got too warm. There's no good angle for that. Okay, it's really barbaric what I just did. Seems to do the job. Does it go on? It goes on, so it does the job. But this last ghetto soldering is not really beautiful. Not at all, but it does the job. Yes, it does the job. 70 milliamps. 70 milliamps? 700 milliamps? No, it's not possible that this I think here shows it draws 700 milliamps, but it's not possible. It's only able to transfer 1 watt. Maybe because it's inefficient, but 700 milliamps instead of 200. is very weird. Let's put the device in the case first. Completely. Try to connect it. This will be hard because there's nothing to back it. Yep. And the cable broke off again. Or maybe it's just because I'm not completely... No. Doesn't light up anymore. So the cable broke off again. Did it? Yes, the cable broke off again. Yep, it did. Okay. Let's try to do it the right way. Again, from the start. Remove the thing. Cable is not holding anyway. Okay. Clean the pads. Which don't look beautiful. Damn it, it was the last mile and now I need to redo almost everything. Remove the complete thing. Let's see what I'm doing. Trying to remove the hot glue. At least it's easier. Removing epoxy. It's almost easier to redo it from the start again. Up, yep. broke these tabs off. Yep. I need more USB connectors. Well, we're almost at the start again. Well, by now you know what the end solution is, how it looks like, so you can stop watching, because there will be nothing new added. It's just the same thing again, which you already seen, just having it completed. Up. Tiny blob. So we hold this thing inside on the board. Up. Some magnet wires. Where's my wire? Where's the wire? Actually, you could use it the correct way around. Yep, magnet wire. Okay. And the minus. I expect actually the minus to not hold well, because it's hard to hit the complete pad, so solar sticks to it. But the plus was the issue. This is output this way. The wire, the coating isn't getting away. Nope. Yep. Minus. Plus, at least we know exactly what we need to do until almost the end. Damn it. Don't run solder bridges, though it's not important. It doesn't look well. goes here. Come on, coating. Burn away. It did not burn. Still did not burn. What's happening with you? Why don't you want to burn? Okay, let's try it again. Damn camera, I don't see anything. Second. Okay, that was a lot faster. Now we have the wire connected for the output. Damn it, this was the input, right? This is the input, this is the output. I'm getting tired. I lose concentration. Yes, this is the input. And no one is in the chat to tell me the mistake I made. This is ground, this is plus. Yep. Solar joint looks shitty, but it does jump. project to be side cutter. Trash bin immediately. I guess I'll have a spare one. Ground. Tiny bit more preheat because the surface is large. Up, up. Okay, seems to hold. I'll try it out. Up. Ground plus this box. It draws 500 milliamp. Okay, it does 500 milliamp. Maybe for two. Don't know what the output is. For 200 milliamp output, it draws 100 milliamp input. It's quite a lot, but I do not care. Okay. First part completed. Now the USB connector again, even a third time. This was to be a tiny project and not a day-long work, but here we are. And make them very susceptible to break. And now we have the same issue. How do I hold it in? Glue. I'm trying dirty way to do it. Oh, I'm not even waiting until it cools down before I solder everything. Yep. Oh. Maybe cutting the wire before scraping off helps with removing the coating. Yes, I think because we do touch the inner copper wire, which transfers heat inside and allows the isolation to be burned also on the inside. I don't know, that's just, I guess, but it works a lot better. So, test if it works. The glue is still not dried, but I'm getting very impatient. It works. We have red lights. Up. No, I have to leave it on while we add even more glue to it. That's not the idea. Don't I have another box, something like that? I can put this on this way. Okay. As long as the light is on, it is working. And I've added so much glue that it melted the one which is below it, because it was warm enough and had enough energy. Whoa. The transformer is getting warm. Didn't expect it. Can still touch it, but it is warm. Yeah, that's surprising. Well, 600 milliamps are going inside. Still, it's not something I really expected that it's getting warm. Problem is, if it's getting warm, the glue is not melting. The glue is not... I'm trying. I hope it has an internal, I don't know, limiting capability, so it doesn't show too much current. I don't know. Seems to be a lot of energy for now because it just charges the battery. I hope. Charge the battery. We can measure it afterwards. We can measure it now actually. Multimeter. Up the leads of the battery. I need to wait a bit. It is tiny bit dry. Battery plus, battery minus. Battery, if we have... The battery is at 3.7 volts. And if I probe now, 3.9. So it is going up, so it is charging. 3.7? Okay. I thought it was charged, because last time I charged it completely. Does it have an internal discharge? This is surprising. It is so flat. Yeah, 3.7. Okay, it looks dry enough. Up. Up. That doesn't look perfect here. Could grab it better. Up. Now let's put it in the case. Although it is still not cold, I'm really not patient anymore. I'm sure we'll make mistakes because I am impatient. But c'est la vie. Now the hard part. Still charging. Okay. And the connector is on it. And can we see it? Yeah, orange. It is charging. And now I just need to add a lot of glue from this side, and I will add it from here also. But for now, from this side, and not too much because it's melting the case. Okay, I've added a bit. I will push it, help it go backwards. Up. Okay, it's on my tool. I don't. Okay, can still clean the tool afterwards. Up. Go down. I want you to help the battery to stay solid, the connector to stay at the bottom. That's good enough. Add some to the side. Still hope I don't put too much glue. Okay, that's to the side. Oh, my tool looks a mess. Once it's dried, it's easy to remove. Wow, let's wait until it cools down. I don't know. Don't wait. Does it still work? Yes, it does still work. Now let's pour from this side. Up, up. Oh, it's really warm. Up. Okay. I poured from this side. I really see it melts the plastic. Meh, meh. I don't care. Still, I think it will still work. Okay, it looks like a mess inside. Plenty of glue everywhere, but it works. and that's the most important thing. Now, is the output working? What does my multimeter say? Do we have 9 volts? 9 volts. Ah, so the battery gets drained even if I'm not using it because it's always putting 9 volts and it doesn't have a cutoff. That's why the battery gets always used if I don't use it all the time. I think the boost voltage circuit still draws tiny bits of current all the time because the battery is so small. Okay, up. See, I'm not patient at all. Let's wait. So it should be this way, I think. It is getting cramped, but it is working. This is still working. Yes, it is red. Now the question is, will I be able to remove the connector, the plug? Yes. Let's remove this tiny bit of plastic. Will I be able to plug it again? This way. Yes. Will it charge? It does charge. Now, let's put it in this thing here. Still the same, yes. This will hold it down, even if this case here is not welded anymore. It holds down well. Up. I still have access to the circuit. The screw. And we want to test it before. So here, let's test it before we may put the screw. Okay. Lights red, so it works. And normally, I should be able to measure. Let's first measure the voltage reference. Up. The desk looks like a mess. That's not a surprise. Voltage reference. 5 volts. Should be 4.994. Yes. It measures correctly. And it doesn't tell that the battery is empty. And now the most important part is testing USB if there is any kind of connection between both of them. So the other multimeter, come here. This I can switch off. The other multimeter, let's put it into ohms. Up. With the leads, they work. So we measure 0 volts, 0 ohm, and let's now try to measure the resistance of plus and minus. Yes, let's remove these things. Here's plus. Do we have plus somewhere here? No, OL. So there's no connection at all. Here, plus, there's no connection at all here. Well, there shouldn't be any here, but who knows? Tack. With minus to plus, there's still nothing. Does this still work? Yes, minus, the most important one. No, nothing. It's completely isolated. So now we have an isolated thing which we can all the time plug into power. And what's the advantage is that this one always has, like the S says, it always has an output. So what I can do and what I will do is connect this thing temporarily, this data logger temporarily to the USB, and I could even have, I don't care, to the USB, and this way I can always have the data from the multimeter to my computer, and yeah, have some kind of logging, or you can actually see what is on the multimeter. That's actually not a good point, because since it will stand here, the multimeter will stand here, you will see nothing. So if I put the logging on here, you will see what I'm measuring with my multimeter. Neat, isn't it? But that works. And up, does charging still work? Up, charging still works. And now we have kind of a bench multimeter because it will always be powered on. It doesn't have an auto switch off mode. It will sit on the bench all the time with the leads long enough. It has a higher, let's go here. It has one digit, it has one digit more, which is useful. The digits are a bit smaller because same screen, but one digit more. So they added a bit smaller, but it's still very visible for a bench multimeter. This will be my new bench multimeter until I have something else. And with that, the project is complete finally, after 4 hours. Yeah, at least one more than I expected. But I've explained everything. And yeah, I have a bench multimeter now with logging, and you will be able to see the measurements without me showing you screen. I can put it on the back, on the bottom. That's it for now. So probably next week there will be a follow-up to the DMX control DC motor. I went to the club and I've installed it. It works kind of. So I will show pictures and I will do the extension. So until next week, enjoy.